Fresh recording. Without all of my swearing at the internet. Woohoo! Not that I swore. Okay, so we are going to be going through exponent laws. It's been a minute since we went through the details of them, and we're going to need them. So we're going to go through some exponent rules, exponent laws, all that jazz today. So, I just kind of wrote out an exponent kind of system here so that we can talk a couple of things through with this, just in case we don't remember exponents, because it's been, a couple of months since we mathed, at the very least, which is fine. I didn't math over the summer either. Yes, I use math as a verb. I don't care. All right, so when we say something is like squared, what does that mean if I was to write this out long ways?
A times A.
A times A. And if it was A cubed? A times A times A. And A to the fourth. We get the pattern, right? A to the first, that's just A. What's A to the 0? 1. Another way to think about that is when we were going up, we were multiplying by A. When we go down, it's dividing by A. So it's canceling 1 out as we go down. Canceling 1 out, canceling 1 out, canceling 1 out, not 0. Sorry, I wrote that wrong. Call me out if you see that. 1. Y'all said it, I wrote wrong. If you see me do that, please call me out. 100% valid. I make mistakes. So anything raised to a 0 power is 1, because A divided by A, think of it as canceling out, is 1. Okay? How about when we have those negative exponents? Remember what that means? 1 over. It's the same thing. We divided by A. We divided by A. We're going to divide by A. So it's 1 over A. How about when it's negative A, or A to the negative 2? 1 over A squared, or 1 over A times A. So that negative exponent makes that particular term flip. That's the other most common mistake, is we think it applies to everybody. It's just to the one guy. A flips, divides by A. So the negative exponents are going to come up a lot today, and remembering our exponent laws is going to come up a lot today. So we're going to go through them all, I promise. Do I need more time on that page? Because I know it's lots of A's, if you wrote them. Okay. So these are our old school Algebra 1 exponent laws. These are, like, you've seen these before. And if you remember them, great. If you don't, write them down. I'm going to close this door, because it's a little loud out there. These are in your book. Like, this is straight up a screenshot from inside your textbook. Or a digital copy. And I know there's lots of variables here, but these are things that you guys know how to do. If you think about this as like 2 to the 3rd times,
is there something else I can help?
Not you, nosy lady. Times 2 to the 5th. We wind up with 2 to the what? 2 to the 8th. 2 to the 3rd times 2 to the 5th. You add your exponents. So if we multiply the bases, we add the exponents. We're going to do a little example of each of these laws just because we see it, because sometimes when it's with the variables, we go, huh? But if we think about it as numbers, it makes a lot more sense, or is familiar. Okay, so we're just going to do a fast example of each one of these. So if we do this power rule, oh, that's right, fire drill, left out the door, left out door 7 south here. thought we had a fire drill today.
Give me 25.
Yes. Yeah, that we'll get through that too. Yeah. We're gonna do a little example of every single one of them. Alright. After that lovely little outdoor interlude where we went to a lovely little humid sauna for like 5 minutes. Holy cow, is it humid out there? Just know if we ever have another one of those, I always grab my blankets because there's always someone in a mini skirt in the middle of December when we have a fire drill. So I always grab the blankets. Or in case it starts to rain. Alright, so we're going to keep working through these. Just kind of doing a refresh. That is not what I meant to do. There we go. You can see the whole thing. And I'll just switch colors in between each of these that we do. So one is in the blue. I'll do this one in purple. So if we did 2, I'll do 2 to the 3rd again. But this time we're going to raise the whole thing to the power of 5. What are we going to wind up with? 15. Because it's 2 to the 3rd times 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 2 to the 3rd. 2 to the 3rd 5 times, which gives us 15 total pieces in the exponent. Okay? So 3 we're going to use a lot more. So 3, 4, and 5 are a lot more for simplifying stuff. We're going to use these a lot. So when we have a power over a quantity, so let's say we have 2 times, so we'll just do 2x to the 3rd. Oh, I didn't change colors. Sorry. All I'm doing is change this color. It's going to be the exact same problem. 2x to the 3rd. You can rewrite this as 2 to the 3rd x to the 3rd. So it feels like distribution. It really does. It's not. It's powers over quantity. It's a power rule. But it feels like distribution. And it's like, that's fine. You could simplify this further. 2 to the 3rd we can do. 2 to the 3rd is 8. So we could simplify this down. That's what this is looking at. It's looking at that simplifying. All right, so I need another color now. Let's go red. So let's look at this fraction one. It's the same kind of deal. If I had the fraction of 2 thirds to the 5th. So we're just going to keep using 2, 3, and 5. I don't know why, but I'm in a 2, 3, and 5 vibes kind of mood. We can rewrite this as 2 to the 5th over 3 to the 5th. That is significantly easier to simplify than 2 thirds times 2 thirds times 2 thirds times 2 thirds times 2 thirds. Especially if it got to be more and more and more. If it was like 2x squared y over 3x to the 5th. Trying to do all of that many times and writing it out the long way. Doable, totally valid, but harder. Okay, so it's more about this kind of simplifying using the laws. And 5A and B are showing the same thing. It's just B is being extra and obnoxious about it. 5A is significantly more realistic on what we're gonna do. So I need yet another color. Let's go orange. I'll go kind of rust. There we go. So the important thing to notice here is that these bases are the same. So this is 2 to the 5th over 2 squared. Which it's easy to see where this subtraction comes in if we write it out like we did the A's on the first place. 2 times 2 times 2 times 2 times 2. I'm going to write it out long way. 2 times 2. What happens with some of these 2's? They cancel out. 2 of the 2's cancel out. So what we wind up with, does this orange show up over here? Can you read that? 2 to the 5 minus 2. Which gave us 2 to the 3rd. We were left with 3 of these guys left over. Can you see that? Okay. If ever it's a color issue where you can't see what I'm writing, please let me know. I can switch it very easily. Okay? I have a tendency to use way too many colors because it makes me happy. So if it ever becomes a problem, please let me know. Okay, it's doing the same thing here. B is really what happens if you have it upside down and have the bigger number on the bottom. You wind up with your leftovers in the bottom, and that's okay too. We can do one like that. If we had it upside down and we had 2 squared over 2 to the 5th, you can even do it written out the same way. 2 times 2 over 5 of them. And they look more and more like Z's the more times I write them. And again, they cancel out. And we're left with our 2 to the 3rd, but it's in the bottom. So you can still wind up with things in your denominator using the subtraction method. If you did it the same way we did in A, you'd wind up with 2 to the minus 3, which just means it flips down, just like we did with our negative exponents on the first one. Okay, so it's a matter of where your bigger exponent is. Okay. How are we feeling on these? A little familiar? Okay. I'm going to say, because they're not new, but sometimes it's been a minute. And that's okay. We go through them. Okay, so we're going to practice it a little. We're going to simplify some. And these are very similar to some in the homework. I pull our practice problems very carefully. Okay? So when we're looking to simplify, and I'm going to change my thing so we can zoom it in. So I'm going to zoom it in on just the one of them. We're just going to do this one to start with. There we go. So this one only has one exponent law that we can use. We're going to use our power over the fraction thing. We're going to have our negative 2 to the 4th over 3 to the 4th. And now we could simplify this more. We can probably do negative 2 to the 4th. Is 2 times 2 is 4 times 2 is 8 times 2 is 16. Is it going to be positive 16 or negative 16?
Positive.
Positive. Be careful. If you type into your calculator just like this, it'll probably tell you negative. Calculators are really bad at order of operations. If you want to, like if you're using a calculator, put your parentheses around the negative numbers. It's important. Okay, what's 3 to the 4th? 81. And actually, that's fully simplified. We can't go any further because 81's not even, 16 doesn't divide by 3, and those are the smallest factors. That's your fully simplified answer right there. And we're going to look at this one. I'm going to zoom it in so we can actually see what's going on here. So this has a lot more pieces here. We're going to simplify the top. We're going to simplify the bottom. It's going to be a whole deal. What does it mean when our parentheses are smashed together again? What operation is that? Multiplication. So the way that I do this, and I feel like makes it easier, is simplify your top, simplify the bottom, and then work on between the two. So when we simplify this top, 2x cubed times 3x squared. What are we going to have? Yeah, because what this is we can rearrange it if it helps. 2 times 3 times x to the third times x squared. You do not have to write that step if it doesn't help you. Like, I will always write more steps than you necessarily have to have. But for somebody, that's going to help. So 2 times 3 gives us 6, and we get x to the 5th. The bases are multiplied, so we add our exponents. What is going on in our denominator? What do we have there? Yes. I heard it. It was whispered, but it was there. X to the 6th. So x to the 6th. We can keep going and keep simplifying here. Oh, sorry. I will leave the next step above it. 6 over x. Yeah, because I have 5 x's on the top, 6 x's on the bottom. So we're going to wind up with 6 over x. And this is our simplified answer. And this was our simplified answer. Questions on those two? There are, I want to say, 4 or so questions like this on the homework for today, where you're working with these exponent laws and simplifying statements like this as far as you can. And when you get to the point where you can't go any farther, just stop. Okay? Questions on either of these two? Sweet. Because we're going to work radicals too. They had very similar laws. We've got to remember the terms radical, radicand, and index. The radical is the shape itself. That guy's a radical. The radicand is the home slice inside. This guy is our radicand. The index is the guy in the little crook. So whether it's a square root, cube root, fifth root, eighth root. We really only have special names for square and cube for 2 and 3. But any more than that, we just use the number fifth root, eighth root, 12th root, whatever. I love when my pictures move when I use a different software. That's so much fun. And we'll do a very similar thing where we go through these laws and practice them, just separating them out using different terms in these, because when you have A and B too many dang times, you go, what? And all this is saying is that when you have 2 terms that are multiplied inside a radical, you can split them apart and deal with them on their own, because that's a lot of times way easier. And I will zoom it in so we can see it, and it's a little higher up because I see us stretching down at the bottom. Boop, there we go. If y'all ever need me to move things up too, please let me know. I can do that. Assuming that the internet's working properly and I have internet to do. So I'm just going to do these with square roots when we're going through the laws, because the different indexes don't make a dang difference right now. So let's pretend we have the square root, way too skinny of a pen, square root of 2x. Or actually, no, I'm going to make 4x. If we were asked to simplify that, I could split that to be the square root of 4 and the square root of x. Since it was 4 times x here, we can do the square root of 4 times the square root of x. Which then we can use that to simplify. Square root of 4 is what? 2. Square root of x, we don't know. We can just leave it as square root of x. So that's the benefit of splitting like that, is if you break it down into smaller chunks, they're easier to deal with if you kind of zoom it in. Okay? So when your terms are multiplied, you can split them into their own little radicals. That's true with fractions as well. If we have the square root, I don't know why I made that square root so wide. We're doing tall. We did a fraction, square root of 16 over 25. You might be able to spot that one because we're doing all right. We can split this to be the square root of 16 over the square root of 25. Which we can then simplify. Square root of 16 we know is 4. Square root of 25 is 5. But the square root of 16/25, that's a little tougher. Okay, so in order to make them easier to process individually, we can split them up into smaller pieces. And 3 is just extra. It is not a commonly done thing where we have roots of roots. It's honestly incredibly bad math grammar. If we had the square root of the cube root of x, honestly, this is not a problem that we see frequently. Genuinely, I had not seen it until I opened this book. Like, they're that rarely done. Okay? But what we do is we take our index. When there's not one written here, what's the index here? 2. That's the kind of the default state. So we wind up with a new index of 2 times 3. 2 times 3. So our new index is 6. Genuinely, aside from this particular lesson, we will not see these root of a root. I've never seen them before in my life. Okay? But they put them there, so we're going to talk about them just in case they bring them back another time for some ridiculous reason. Because I don't get to write the finals, so we talk about it just in case. Okay? Okay. And we're going to practice doing some of those kinds of problems too. Square root of 28. It does not look like any of those rules that we just saw. That just looks like a number. What are some factors of 28? I can rewrite 28 as 7 and 4. So I could rewrite this as 7 times 4. Now that starts to look like one of those previous things we did. We can do square root of 7 times square root of 4. Do we know the square root of 4? Yep, square root of 4 is 2. Do we know the square root of 7? But we can leave that as square root of 7. I put my whole numbers in front just because then it's really clear where my radical ends. If you do square root of 7 times 2, it's a lot harder to tell if the 2 is still in that root, if that's 72 or whatnot. So best math grammar has you put your whole numbers in front. But as long as you make it clear if something's being multiplied or not, right now I don't really care. But this is better math grammar. Just put your numbers and your variables that are outside the radical in front of the radical. Okay? This works the same with cube roots or fourth roots or fifth roots as it does on square roots. So if we bring it in here, I'm going to zoom it in so we can see because the teal and the black are not as high contrast as I thought they were. We can do the same thing like we did with those radical, or like we did with the variables on the first. I can take and split this into 2 different pieces because the cube root of 8/27, I don't know that off the top of my head. But the cube root of 8 over the cube root of 27, that we can think a little clearer on. Because then I can just look at, oh gosh, it's stuck to the table. Love that. Cube root of 8. We can think about that. Do we know cube root of 8? 2. 2 cubed is 8, so this becomes 2 over, what's the cube root of 27? 3. So this is just crazy notation for 2/3. Means the same thing. Okay, so we're just breaking it into chunks using these rules. Okay? Let me see if we have... We should have time for this. Checking. You know what? We'll talk about these tomorrow because of the fire drill. Okay? So you've probably seen these, but I'll make sure I get them on tomorrow's slides too. Fraction exponents. We'll talk about those tomorrow though. So maybe not 46 and 54 today. But the white ones should be the ones we've done, but there's a couple of those fractional index, the fraction exponents that'll be on there. This is homework 2. And I don't have it up here yet, but it should be on that paper that I gave you guys last week. But it's also up there. It'll also be posted on there on the Canvas page. Okay? Yeah, it's the same ones that are on the grid sheet that I gave you guys last week. There's also extra copies of that in the hanging file folder under the pencil on the back wall. I'll always keep extra copies. If you ever need another one, absolutely no shade to that. I lose stuff all the time. I will pass out homework 1-1 tomorrow, so make sure you turn it in if you didn't yet today. You guys have about 5 minutes left in the period. So you can start on stuff, ask questions, whatever you need to do. Or if you need a quick finish 1-1, do so now. Okay? But we'll talk about the fractional exponents tomorrow. Just because when I was planning, I forgot there was a fire drill today.